Hi guys, this is Mrs. Allison. Today we are going to start our unit of polynomials, and there's lots of things that we get to do with polynomials. And really we should know what a polynomial is because we've dealt with them before. So let's dive right in and see what we can define. If we were to look at the prefix of the word polynomial, we'd see that word poly. What does poly mean? Right, it means many. And so if we talk about a polynomial is simply an expression, not an equation, just an expression, but it's consisting of many, hence the word poly, or that prefix poly. It's consisting of many monomials. And remember, a monomial is just a single term. It could be a number, it could be a variable, it could be a product of a number and a variable. We talked about monomials back several times. In Unit 6.1 we did it, and we did it back in the beginning of the year. So let's look at some examples of a polynomial. -5. -5 is technically a polynomial. It's an expression, and it consists of monomials. Granted, a single monomial, so not very exciting. We have -6x plus 3. This is a polynomial. We have an expression, not an equation, that has two monomials. Now, we might give this a more specific name. We've talked about these before with two terms being a binomial. We're going to reference that here in just a moment again. Another polynomial might be something like 4x squared plus 3x minus 7. This is a polynomial. We happen to have three terms. But our polynomial could even be as complicated as having several different variables. 7a squared b, single term, minus 2a, plus 3b, minus 7c. This is an example of a polynomial. It is an expression consisting of multiple monomials. Okay, now the next thing that has to be true about polynomials is that they need to be in standard form. So when we talk about standard form, polynomials are written in alphabetical order. And then with the highest exponent terms first. So our highest exponents will be listed first in alphabetical order. So we would want all of our, say, for example, our A's to be listed before our B's. Now, if we have a term that has both, we start with the first variable alphabetically. So let's start with the A. So let's look at some examples of writing polynomials in standard form. If we look at this first example here, I see this 3x plus 1 plus 2x squared. So I see that everything is in terms of x's. So if I'm going to write this in alphabetical order, don't have to worry with all x's, but with the highest exponent first, then the first term that I need to deal with is this 2x squared. That will be my highest term. And so I'm going to list that term first, 2x squared. And then I need to keep going and list my next highest exponent term first, or next. And in this case, that would be 3x. So this would be 2x squared plus 3x plus 1. Okay, so now what I would like you to do is with your seat partner, try example 2 and then example 3, which is a little bit messy, but let's try example 3 next. All right, hopefully you had a chance to look at example 2. And so let's go through and list our highest exponent. It's pretty easy to see our highest exponent is going to be this, this term, this 7k cubed. And so if I list that first, we've got 7k cubed. My next highest exponent would be this positive k squared. And my next highest exponent would be this minus k. And finally, I put the plus 64 at the very end. It's a constant, so our constants are going to be at the end. How'd you do? All right, with example 3, though, it gets a little bit messier because we've got multiple variables. And actually, if you watch several different videos, some people will treat the exponents first and deal with the highest exponents and then go to the alphabetical, and some will do the alphabetical first and go to the highest exponents. I tend to do my exponents first and then worry about alphabetical, meaning if I have a bunch of terms that have the same highest exponent, I'm going to list them alphabetically and then work my way down the exponents. So on this particular problem, I might say a cubed. That's undeniable. That's the highest exponent and in alphabetical order. Then I would probably do negative 2b cubed. And then I'm going to do positive 5a squared b squared. And then I'm going to finally do 2ab that doesn't have any other exponents, and that's the order I would do this in. So you can see I have alphabetical A, then B, and yes, I have an AB here and an AB here, but notice then it goes by powers. So I have a cube and a squared, and then a single variable. That's how I would do it. Now, most of the time, we're going to be focused on example 2 or example 1 when we talk standard form. Okay, the next way that we talk about polynomials is by classifying polynomials. And what I mean by classifying polynomials is we talk about their degree, and we'll define degree here in just a second, and then their number of terms. Does anybody remember another name for degree? We've talked about it before. But degree is simply the highest exponent. Now, some of these degrees have special names. Okay, so let's start looking at them. If I have a 0 as my highest degree, it means that I'm dealing with a constant equation or a constant expression. Now, what does it look like to have a 0 as a degree? Well, it means we would write something like negative 3x to the 0. Well, that's silly. We know from last chapter that x to the 0, we just don't typically write. And so this is equivalent to just negative 3 times 1 or negative 3. So what we would see written is just negative 3. That means its highest exponent is 0 because there isn't any x's listed. So negative 3, 5, 7, those are all examples of constant terms if we label them by degree. The first degree terms are something that are linear. So some examples we might see. 2x plus 3. This is considered linear or degree 1 because even though it's not written, there's a 1 for this exponent. Now, we don't have to have two terms. Sometimes we just have something like negative 7x, and that is a linear term. All right, degree 2. We refer to this as a quadratic. We could call it a degree 2, but oftentimes this has a special name of a quadratic. So a quadratic might look something like negative x squared plus 4x minus 5. This is an example of a quadratic because my highest exponent happens to be a 2. Now, we don't have to have 3 terms. Maybe we just have 2 terms or 1 term. As long as the highest exponent is squared, this polynomial would be called quadratic. Now, if my degree is 3, we call this a cubic polynomial. A cubic polynomial might be something like 7x cubed minus 2x plus 1. This is an example of a cubic polynomial because my highest degree is 3. Now, really, anything above 3, we don't really give a name to. Although there are names, there are words we could use for these. So, for example, a 4th degree could be called a quartic, but it's just not a word we use very often. So as we get above 3, so 4 and above, we typically just call it by the degree number it is. So this is a 4th degree polynomial. And a 4th degree polynomial just means that the highest exponent is 4. Now, here's a couple tricky things. If my problem's not in standard form, my highest exponent might not be at the front, which is why it's important that we write things in standard form so that we can quickly look at it and know what my highest degree is. All right, let's also go over to the number of terms, because the number of terms will help us classify these polynomials even more. Sometimes it's just nice to know what we're working with, and that's why we look at both degree and number of terms. Well, some of these we know. If I have one term, it's called a monomial. We know this. We've done monomials before, right? A monomial is something like 3x or 5 or 7x squared or anything that is just a single term. So if we look at this, my first monomial 3x is a linear monomial because the highest exponent is a 1. My next term is a constant monomial because its highest degree is 0. My next term is a quadratic monomial because my highest exponent is a 2. And we can continue this pattern. If I have 2 terms, we know this is called a binomial. 2 terms. Bi means 2. And a binomial could be something like 2x plus 7 or 8x squared minus 9x. These would be examples of binomials. 3 terms. If we happen to have 3 terms, we refer to this as a trinomial. Prefix means tri means 3. And again, we could have any number of degrees. So I could have a trinomial something like 4x squared plus 3x minus 7. Or maybe my trinomial actually starts with 8x to the 5th minus 4x plus 2. Who knows, as long as I have 3 terms. So this first one is a quadratic, highest degree is 2, quadratic trinomial. The next one is a 5th degree trinomial because it's the highest exponent is a 5. Now, as far as number of terms go, we really don't classify them beyond the monomial, binomial, trinomial. Anything above that, we just call it an n-term polynomial, whatever n happens to be. So if n is 5, meaning I have 5 terms, we just call it a 5-term polynomial. Okay, so now what I want you to do with your neighbors is look at example 4, 5, 6, 7, 8, and 9, and classify each polynomial by, we're going to do it by degree, and then we're going to do it by number of terms. So my degree and my number of terms. So there should be 2 words, or at least 2 words, describing each of these polynomials. So hit pause and then come back and check your work. All right, example 4, we have 6. This is a constant monomial. So constant refers to the degree. Monomial refers to the number of terms. So this is a degree 0 and it's 1 term, so this is a constant monomial. All right, my next term, example 5, would be a linear monomial. So linear would be, linear would be the degree, and monomial would be the number of terms. There's 1 term, and the highest exponent here is 1. Even though it's not written, the highest exponent here is 1. All right, what about example 6? If you said linear binomial, you would be correct. This is a linear binomial. Linear, highest degree is 1. Binomial, there's 2 terms. Okay, maybe you didn't get those first 3. If you didn't, hit pause and try the next 3 and see what you come up with. Otherwise, keep checking. Example 7 should be a quadratic trinomial. Quadratic because my highest exponent is 2. Trinomial, so quadratic because my highest exponent is 2. And a trinomial because there are 1, 2, 3 terms. All right, next one would be a cubic binomial. And finally, my last one, example 9. I see my highest degree is 4, so this would be a quartic. And if I count the number of terms that I have here, I see 1, 2, 3, 4. I see 4 terms, so we would call this a 4-term polynomial. I'm just going to abbreviate that. This would be a 4-term polynomial. So quartic refers to the highest exponent. 4-term polynomial refers to 4 terms. Okay, so just like our monomials, just like our binomials that we've worked with, if I want to add and subtract polynomials, all I have to do is combine like terms. Oh, so add or subtract polynomials by combining like terms. That's it. Okay, let's review. Just to make sure we're all on the same page, what does it mean to be a like term? We have to have the same what? Same variable with the same exponent. So if I have an x squared and an x squared, I can combine them. But if I have an x squared and an x, I cannot. We have done like terms so many times. Now, the one thing that's going to be different now from before is we're going to want our answer in standard form. So we want our answer in standard form. That's going to be the difference between what we've done before and what we're doing now. Okay, so let's look at the first example. Example 10 says I want to add 11x minus x squared plus 13 plus 2x squared minus 23 minus 5x. Now, it didn't ask, but if I were to classify this, first of all, not in standard form, notice the x squared comes second, and it's the highest exponent. It should come first. But I see 3 terms, and the highest degree is 2. This would be a quadratic trinomial, much like example 7. And so too would be the second part of 2x squared minus 23 minus 5x. I have 3 terms, and my highest degree is 2, so this is also a quadratic trinomial. Knowing that I want my answer in standard form, the first thing I'm going to do is find my highest exponents. And I see I have a negative x squared and a positive 2x squared. So the first thing I'm going to do is add those two together. That's going to give me positive x squared. So negative x squared plus 2x squared. Combining those together, I get a positive x squared. The next thing I'm going to look at is my 11x with my negative 5x. And if I combine those, I've got a positive 11x and a negative 5x. Adding like terms, that's going to give me positive 6x. And then finally, I'm going to look at my constants. I've got a positive 13 and a negative 23. No x's in sights for those two, so I've got positive 13, negative 23, which would give me negative 10. And as long as we are in standard form, we are good. My highest exponent is listed first, then my next highest exponent, and then finally my answers would be x squared plus 6x minus 10. All right, I'd like you to try example 11, but there is a trick on example 11. I'm going to caution you to be very careful about that negative sign. Remember, a negative sign needs to be distributed to everything in the parentheses. So maybe it helps you to write this out as 4x squared plus 5x minus 7x minus 3x squared minus 1. Now try. Combine like terms. All right, so my first like term, if we start here with my highest exponent, I see a 4x squared, positive 4x squared, and a negative 3x squared. When I combine those, I get positive 1x squared. You can write just x squared or positive 1x squared. Then my next term I'm going to look for are my x's. I have a positive 5x and a negative 7x, and together those make negative 2x. And then finally, I'm going to look at my constants. Well, I just happen to have one constant, so I don't really have any other like terms with it, so we're just going to put minus 1. And my final answer to this would be x squared minus 2x minus 1. All things we've seen before. Now we're just adding some vocab. Now, if you finish that and you feel a little bit uncomfortable, feel free to rewatch the video again and get clarification on the parts that you didn't understand. For those of you that feel good, you have an assignment called 7-1, Intro to Polynomials.